This is exercise 2-5, generalizing the linear model. So we are going to use generalize the linear model here. And as we learned before, we have assuming that the response variable is following normal distribution. But in reality, sometimes it may not follow normal distribution. It may follow other distribution like binomial distribution or Poisson distribution and so forth. At that time, we can still use a linear model if we generalize it. So in this exercise, we are going to learn how to do so. In this demonstration, the target variable is modified. We want to, apply log function because usually the sales number is skewed to the right very severely. And one remedy is to apply log function as we have done in exercise 1 or module 1. We are going to do that here in this exercise. So create a new pane like this. And now let's go to object, and we can go to scroll down under visual statistics. We have generalized linear model. So click on it or drag it to your canvas, and then you have the model. And make sure that under your filter you have nothing there. I used other things before, like if I go to report 1, I used other filters there. So make sure that you don't have any filters. So and let's go to now options. And you have, if you have not selected the generalized linear model, make sure you do that. And then go to under generalized linear model, we have a variable selection method and distribution and link function. We are going to use link function as log function. And then in the option panes, under model display, change the plot layout to stack to expand the fit summary pane on the canvas. So let's go to display and then to stack. So at this point in my data, I don't have any data assigned here. So that's why this is happening. So what you can do is go back here and add the data as I have done before, response variable and continuous variable, log RFI 1, 2, 9, 12, so 12 of them, add them, and we also added classification 1 and 2 before, and interaction effect is RFM interaction. So you add them all, and it's going to run. The result will appear like this. And because you made it a stack, you see fit summary and residual and assessment separately right here. Let's examine the residual plot here. Residual is very important, so let's take a look at it. Right-click and change to standardized Pearson residual. Okay, so here, click on it, residual, change it to standardized Pearson residual. The residual plot still shows the signs of heteroscedastic residual variance. This and the remaining bias seen above might be a result of the very large target observations. Because we have a lot of numbers, 50,000, 500,000, $1 million. So it's a large number, and because of that, we might have the problem here. This plot indicates some possible problems with the fitted model. It might not be the best model. The assessment plot also, let's take a look at assessment plot. The assessment plot also shows evidence that model prediction bias, at least at the lower end of the target variable range, is mitigated over here. So we have observed average and predicted average, and there, it should closely follow observed average, but there are some gaps, and at least here, there are large gaps, and that's problematic. In the upper right corner, click Menu and select Save As, or you can say Share. So here you can, instead of, because Save As function is not available here, maybe you can just share object, and it says you must save a report before you can share a link to a report. So let's say save, and you want to go to my folder and name it as VS Bank, VS Bank interval, and click save. Then it's saving, and it's giving you the embedded link. This is a link that you can use. If you use this one, say you go to any other web page, and it will display for you. Okay, this summary, residual, assessment, everything is displayed here.